what I'm going to be talking about now is I'm going to go a little bit into more detail about double replacement reactions, specifically talking about solubility rules really quickly, and then going into net ionic equations, which we'll have a pretty extensive lab about in about 2 days. All right, so specifically solubility rules. So basically, we can predict what compounds are going to be soluble in solution or not. And very nicely, I've given you a table, and I'll give this to you on the test, a table telling you what is going to be soluble and what is not going to be soluble. And basically what you should do is the following. Okay, I'm going to give you compounds, all right, just like I did here, and you are going to have to predict what's soluble or not. And so the best way to approach this is to look at your negatively charged anion located on your table and then be able to decide whether or not, based on the cation it's bound with, whether it's going to be soluble or not. Okay, so if you notice, we've got 2 columns here. Okay? We've got the soluble column and we've got the insoluble column. Now, the soluble column. If you're in the soluble column, okay, for example, if we look, anything that's a nitrate, an acetate, ammonium, or group 1 salt. So if you have any group 1 metal, if you have a nitrate, so NO3, acetate, C2H3O2, or ammonium, NH4, you're automatically going to be soluble. All right? Pretty simple. But then we get into some exceptions. So let's look at the exceptions. So all chlorides, bromides, and iodides, so any kind of salt that has chloride, bromide, iodide, is going to be soluble except if it has silver, lead, or mercury. So if it's an exception, okay, if it's silver, lead, or mercury that's bound to chloride, bromide, or iodide, then that compound's going to be insoluble. All right? Same thing here. All fluorides, okay, are going to be insoluble except for group 2 metals. So any group 2 metal that is bound to a fluoride is going to be insoluble. Okay? So if you're an exception within the soluble rule, that means you're insoluble. Let's look at the insoluble rule. All carbonates and phosphates, okay, anything that has a carbonate or phosphate is going to be insoluble unless it's a group 1 or ammonium. So if you're an exception within the insoluble column, what that means is that you're going to be soluble. All right, so rather than just trying to piece together and keep talking about this, why don't we actually go through a couple of examples? All right, I've got iron hydroxide. So let's go, remember, you look at your anion first, so OH. Let's find it in my table. So go searching for hydroxide. And I found it. It says all hydroxides except group 1, strontium, barium, and ammonium are going to be insoluble. So is iron group 1? Well, no. Strontium, barium, or ammonium? No. So, since iron is not an exception, it's going to be insoluble. All right? All right, let's look at the next one. NaCl. So let's look at my chlorides. It says all chlorides, Cl, because you wanted to look at your anion, all chlorides, bromides, and iodides except silver, lead, and mercury. Is sodium one of those? Well, no. So therefore, NaCl is soluble. All right, let's look at one more together, and then I'm going to have you do some on your own. SO4 is sulfate. So let's find my sulfate in my roll. Oh, all sulfates except calcium, strontium, barium. Oh, here's an exception. So I've got a sulfate, and I have an exception. So if this is an exception within the soluble rule, what that means is that it's going to be insoluble. Okay, since it's not, when you're an exception, just as a refresher, when you're an exception within the soluble rule, within the soluble column, you are going to be insoluble. Okay, so pause this video right now, please, and complete these next 3 problems, please. All right, let's look at this question. Which anion can be used to pull lead out of solution? So these have real-life applications. How can we get lead out of our water, for example? So let's see what we can do. So if we're wanting to pull lead out of solution, all right? What that means is we're wanting to create a solid, all right? Meaning we're wanting it to be insoluble, right? To create that solid. We don't want it dissolved in our water. So let's see what makes lead insoluble. Okay, let's find where lead is. Oh, there we go. All fluorides except group 2, lead and iron, are going to be soluble, which means lead fluoride is going to be insoluble. Okay, same with chloride, bromides, and iodides. Lead is also an exception. So any of these anions, Cl, Br, I, and F, are going to pull lead out of solution, meaning they're going to make it insoluble. Okay. So I'm going to skip this next one. If you want to do it as a challenge problem, that'd be awesome, but I'm going to skip it right now because we need enough time to go through at least one net ionic reaction together. All right. So what we do in net ionic equations. So basically what we're interested in net ionic equations, all right, is what exactly is reacting. All right. So I'm going to walk you through it. The first thing you do is just do a typical double replacement reaction. So I'm going to do my outies. So Pb and Cl and Na and NO3 are going to react. So Pb has a plus, well, look at here. You've got NO3, which has a -1 charge, but you've got 2 of them, which means Pb has a +2 charge. Cl has a -1 charge. So I'm going to create Pb, Cl2, because Pb has a +2 charge, and Na, NO3 as my other product, all right? Now I need to balance really quickly. I've got 1 Pb, good. 1 Cl, 2 Cls, that's not good. So I'm going to make that a 2 right there. Now I've got 2 NAs, 1 Na here, so I'm going to put a 2 here. 2 Ns, 2 Ns, 6 Os, 6 Os. All right, so I'm actually done now. Now, what you have to do for a full ionic reaction is determine what is soluble and what is insoluble, okay? If it is soluble, then you're going to just write them as their ions. If they're insoluble, you're going to leave them as the compound, all right? So this is the trickiest part. So just kind of as a heads up, you can check through them, but I promise you all your reactants are going to be soluble, but let's double check, make sure I didn't make a mistake. Pb and NO3, so let's look at your solubility. This is a good way to review solubility rules. Let's see if this is soluble or insoluble. NO3 is a nitrate. Here we go. And it says all nitrates are soluble. There are no exceptions. So I'm just going to write an S above here to remind myself that this is soluble. Okay. NaCl, well, Cl, it says all chlorides except silver, lead, mercury. Nope, not an exception. So this is also soluble. All right. PbCl2. All chlorides, bromides, and iodides except silver, lead, or mercury. Well, lead is an exception, so therefore it's going to be insoluble. All right? And NaNO3, it says all nitrates are going to be soluble, so this is soluble. Okay? So just as a reminder, for your full ionic, if it is soluble, you need to write them as their ions. If it's insoluble, write them as a compound. So I'm going to divide this up into their ions. So I have Pb, okay, as an ion, well, it's got a 2+ charge, plus I've got my NO3, and here's the only tricky part, guys. You can't have your subscript anymore, but I still have 2 NO3s as a whole, so I'm going to put a 2 out front here as a coefficient, NO3 with a minus charge, because NO3 has a minus charge. Okay. NaCl is also soluble, so I've got 2 NAs, and Na has a plus charge, plus, well, I've got 2 Cls, which also have a minus charge, yields, okay. Remember, since PbCl2 is insoluble, I'm going to leave it as a compound, okay. And then, since NO3 is soluble, I'm going to write that as their ion, so 2Na plus, well, I've got 2 NO3s. Alrighty, now, here comes the fun part. Anything that's the same on the left and right-hand side, I can cross out. So Pb2 plus is definitely not the same thing as PbCl2. All right, they have to be identical on either side. So let's take a look. So that's not the same. 2NO3 minus, 2NO3 minus right there. Yep, those are identical. So I'm going to cross them out. Okay, 2Na plus, yep, identical. I'm going to cross them out. 2Cl minus, PbCl2, nope, not the same. Okay. So this is what I would need to see for your full ionic. Writing out if your compound is soluble, writing out the ions, okay, making sure to bring out that 2 for your coefficient, and then crossing them out if they're the exact same. If you notice that you've got a compound, let's say you have NO3 minus, but 2NO3 here, okay, you did not balance your reaction. So go back and balance it in here. All right. Your net ionic, guys, is just going to be what's left over. So you've got Pb 2 plus 2Cl minus gives me PbCl2. So if you notice, what my net ionic reaction is doing is it's telling me what exactly is happening in the reaction, what I'm really concerned about. Pb is going to react with Cl to form PbCl2. Okay. All these other things, if you notice, they're not changing. NO3 isn't reacting with anything to form a compound. Na isn't doing anything. And as a result, they have their own special name, and we call them spectator ions. Okay. So if they're not doing anything, we're going to write them down as spectator ions. So NO3 is a spectator ion. It's just going to be watching. It's not changing. It's not involved in the reaction. And Na plus is also a spectator ion. All right? So I'm going to start out number 2 with you, and then what I want you to do is kind of use this as a guide, okay, and finish off this one problem. So I'm going to start off and make sure we're all on the same page with double replacement. So here's Ca. It is going to bind with my OH and Ba with Br2. Remember, outies and innies. So Ca has a +2 charge, OH has a -1 charge. Cross my charges, I end up with CaOH2 plus Ba has a 2+ charge, Br has a -1 charge, so BaBr2. And if you notice, this is actually already balanced for you. Okay, so what you need to do is go through each of these, find them on this chart, and decide whether they are soluble or insoluble. If they are soluble, break them up into their ions just like we did. Remembering you can't keep the subscripts, you have to use them as coefficients. Bring it out front, just like I did with NO3. Okay? If it's insoluble, okay, then leave it alone. Okay? Once you've written out your full ionic, cross out things that are the exact same, write out your net ionic, and then write your spectator ions. Really, guys, use this as a key and come into me if you need any help. All right? Good luck.